Okay, so here we are going to be talking about hydrocarbons and their physical properties. All right, so let's talk physical properties of these hydrocarbons. So hydrocarbons contain only carbons and hydrogens, so this is going to make them nonpolar substances. When we're talking about the polarity of our hydrocarbons, they are nonpolar. Now, as a refresher, IMF stands for intermolecular force. And so if these molecules are nonpolar, the only force they're going to experience are dispersion forces. Now, there are two things to keep in mind with dispersion forces. Number one is that the dispersion force is going to increase in strength as the number of electrons increases. So the more atoms we have, the more electrons, the greater the dispersion force is going to be. The second thing to consider is the shape of the molecule. So the larger the exposed surface area, so think about something like a strand of spaghetti or like a pool noodle, that is going to have a large surface area, so we're going to see increased interactions of dispersion forces with something that has a large surface area like that, as opposed to something like a beach ball or something like that. Now we're looking at phase change. These are going to have the lowest melting points and boiling points of the organic compounds that we're looking at. As the chain length increases, the higher the melting points and boiling points will occur. And again, this goes back to the dispersion forces. These dispersion forces are getting stronger as that chain length increases because we have more atoms. In general, for your compounds that have between 1 and 4 carbon atoms, these are going to generally be gases at room temperature. If your compound is anywhere between 5 and 17 carbon atoms, these are generally going to be liquids at room temperature. And 18 plus carbon atoms, these are going to tend to be waxy solids or parabens. Now, as far as the solubility goes, these are going to be insoluble in water, but they will be soluble in nonpolar solvents.